Hi everyone, this is Mrs. Musoff. Today we're going to start talking about the domain of functions. And I know we've talked about domain before when it comes to looking at a graph. So the difference between today is we're going to just be looking at equations and trying to figure out the domain. So we think of this as finding the domain algebraically as opposed to graphically. Alright, so if I asked you to find the domain algebraically, that means I don't want you to use your calculator, I don't really want you to have to graph it, I just want you to be able to know, based on the equation, what the domain would have to be. Alright, so just a reminder, domain is the set of possible inputs, or x values, for a function. Alright, and when we say possible, that means like numbers that you could plug in for x and get a real answer. Right, so if you would get undefined or imaginary answers, then we wouldn't count those numbers as our domain. Alright, up till now, we've actually only learned about 3 possible domain restrictions, just based on the functions that we've learned. Alright, so one of the domain restrictions has to do with the denominator, and that is that you're not allowed to divide by 0. Right, can't divide by 0. So what that means is if there's ever a function that has a denominator with x in the denominator, then whatever is in the denominator, you would set it not equal to 0 and you would solve, and that would tell you what values are not part of your domain. Alright, so if there's a denominator, for example, let's say I had this function right here, alright, 1 divided by x minus 2. What you'll do is you'll take the denominator, so x minus 2, and I'll say that is not allowed to equal 0. So equal sign with a line through it means can't equal. And I would solve that just the same way I would if it was a normal equal sign. I would add 2 to both sides. And that's going to tell me what values cannot be a part of my domain. So in this function, I would say my domain is all real numbers, which remember that's that R with the double line, right? All real numbers, but x cannot equal 2. Because 2, if I were to plug it in, 2 minus 2 would give me 0, and we can't divide by 0. Alright, so with the denominator, the kind of restriction you should think of is the denominator cannot equal 0. That's what you'll always do anytime there's a denominator, right? Cannot equal 0. Alright. Another domain restriction that we've learned about has to do with even roots. And that's to say that you're not allowed to have negative numbers underneath an even root. Right, so no negatives under an even root. Move this over, hope you can see it better. Alright, so for example, if we were to have this function, let's say y equals the square root of x plus 5. Alright, since the square is an even root because there's an imaginary 2 there. Alright, since it's a square root, what I would do is I'd say what's underneath, so x plus 5, cannot be negative. Well, the only way to describe something that can't be negative is to use an inequality symbol. Because if there's a number that's not allowed to be negative, that means it has to be 0 or positive. So we'd say it has to be greater than or equal to 0. So I'll take what's underneath the even root, x plus 5, and I'll say that that has to be greater than or equal to 0. That's how we say can't be negative. And then I'll solve this the normal way. Right, linear inequalities, we basically solve just like regular linear equations. The only difference is to watch out if you're dividing by negatives, then you have to flip the sign, which we're not doing here. All I end up with is x is greater than or equal to negative 5. So again, for my domain, I would say all reals, but x has to be greater than or equal to negative 5. And that's because if I were to plug negative 5 in, negative 5 plus 5 is 0, it's okay to take the square root of 0. But if I were to try any number greater than negative, or less than negative 5, so negative 6, right? Negative 6 plus 5 would give me negative 1. That's what we're not allowed to have, right? No negatives. So if you ever have an even root, the symbol you're going to use to find the domain is we're going to say it has to be greater than or equal to 0. Alright. The last domain restriction is actually just a combination of those top two, and that is you can't have an even root you can have an even root in the denominator. If there's an even root in the denominator, then we kind of combine these two domain restrictions. And that's to say it can't equal 0, and it has to be greater than or equal to 0. And if we put those together, that's really just saying it has to be strictly greater than 0. Okay, so if you were to have an even root in the denominator, so again, to give you an example, let's say something like that. All right, I have 1 divided by the 4th root of x minus 4. So this is an even root, and it's in the denominator. All right, so whenever that happens, what you're going to do is you're going to take what's underneath the even root, x minus 4, and you're going to set it just greater than 0. So not equal because it's also in the denominator, so it can't equal 0. So it'll be just greater than 0, and we'll solve that. And that would be my domain. So my domain would be all real numbers, x has to be greater than 4. All right, so let's try a couple examples. I can show you a little more about what this would look like. Let's see. Okay, so find the domain of the function algebraically. Again, algebraically means try to do it without a graph, right? Try to do it just based on the equation. So in number 1, I have f of x equals 5 divided by x plus 3. So what you'd want to ask yourself is, of these 3, which one do I have? Because that's going to tell you which symbol to use. Okay, so do I have a denominator, do I have an even root, or do I have an even root in the denominator? In number 1, I have a denominator. Right? X plus 3 is in the denominator. Denominators mean we say can't equal 0. So what I'm going to do in number 1, there we go, is I'm going to take the denominator, which is x plus 3, and I'm going to say that cannot equal 0. And then I'll solve. Right? Minus 3 minus 3. So x cannot equal negative 3. So the domain would be all real numbers, but x cannot equal negative 3. All right, that's as simple as it is. There's 3 domain restrictions like we talked about. Figure out which one you've got and use the corresponding symbol. Okay, now it is possible to have none of these, in which case the domain's just all reals. All right, so it doesn't have to be one of these 3. It could be none of them, and then we just say all reals. All right, let's look at number 2. So y equals the square root of 2x minus 6. So since the square root, that is an even root, that means I'm looking for the even root one, which is greater than or equal to 0. So I'm going to take what's underneath, 2x minus 6, and set it greater than or equal to 0. And that's what I'm going to solve. Again, remember, solving linear inequalities, same as equations, the only thing to look out for is if you multiply or divide by a negative to flip the sign. All right, so here, like I'm adding 6, that's okay, I don't have to flip the sign there. I get 2x is greater than or equal to 6. And then divide by 2, 2 is positive, so I don't have to flip the sign there either. So I end up with x is greater than or equal to 3. So this domain would be all reals, but x has to be greater than or equal to 3. All right, number 3, same idea. Okay, 3x plus 1 divided by the square root of 5x plus 10. So now I have a denominator, but I also have an even root in the denominator. So that would be number 3, right? An even root in the denominator. So I would use this symbol, greater than 0. Okay, and so I would take what's inside the root, so 5x plus 10, and I'd say that has to be greater than 0. And then I'd solve that. I'd subtract 10. 5x has to be greater than negative 10. And then divide by 5. Again, remember, since 5 is positive, I don't have to flip the sign. It's only if the number you're dividing by is positive or negative. Or sorry, is negative. Then you have to flip the sign. Okay, so I end up with x is greater than negative 2. So my domain would be all reals. X has to be greater than negative 2. Okay, just to give you a couple extra examples, like number 4, we have h of x equals 2x squared minus 3. When you look at that, hopefully it's obvious right away there's no denominator. Right? But I've had a lot of students in the past get confused between even exponents and even roots. So remember, in this case, even though that exponent is even, it's just an exponent. It is not a root. The only way for an exponent to be a root is if it's a fraction. Right? This exponent is not a fraction. So because of that, there are no restrictions here. There's no denominator, there's no even root, and especially there's no even root in the denominator. So my domain would just be all reals. Okay. Another quick example actually that I'm going to add right down here in this little tiny space that I'm going to squeeze it in is something like this. Suppose you have an odd root. All right, we'll keep it simple. Okay. Odd roots, similarly, do not qualify in any of these domain restrictions. Right? This is just for even roots. Even root here, right? No odd roots. So if you were to ever get a function with an odd root, you would say, oh, awesome, all reals. And that's because you're allowed to have negatives in odd roots. Remember, we talked about that when we did graphing. If you were to type the cubed root of a negative number into your calculator, it would give you an answer. It wouldn't say error. Right? So that's how you know it's okay. Alright, I hope that explains some of this domain stuff to you. Again, remember these 3 restrictions. Those are the 3 you need to focus on. If you feel like you have questions while you're working, just make sure you set up a time to come talk with me. Thanks for tuning in.